Hi guys, this is Nitya, Assistant Professor of Mathematics from St. Anne's Arts and Science College. Today we are going to see some problems based on the odd and even functions. Already we had seen some definitions on odd and even function as well as the problems. Today also we are going to some important problems based on odd and even function. Let us see the first problem. If un equal to integral over 0 to x power n e power minus x dx, then prove that un minus n plus a into un minus 1 plus a into n minus 1 into un minus 2 equal to 0. Solution. So in the solution, what is given? That first what is given? Un is given. That is the integral over 0 to x power n e power minus x dx. We know that un is integral over x power n into e power ax. Formula is x power n into e power ax by a minus n by a into un minus 1. That we know, that we have seen in the reduction formula. Here what is n? N equal to n and a equal to minus 1 we are taking. Now un can be written as x power n into e power minus x by minus 1 minus n by minus 1 into un minus 1 equal to the given reduction formula. In that, in the place of a we have written the minus 1 and in the place of n we have written the n. Now apply the limit 0 to a. So un equal to minus xn e power minus x plus n into un minus 1, then apply the limit 0 to a. So if you are applying the limit, what will happen? Minus a power n, in the place of x we just substituting the value of a. So minus a power n into e power minus a plus n into un minus 1. In the 0 terms becomes as 0. So if you are applying 0, you will get 0 only. Now take the un terms to be this side. So un minus n into un minus 1 equal to the remaining term minus a power n into e power minus a. Take that as a first and second equation. Now from the equation 1, what is equation 1? Un equal to minus x power n e power minus x plus n into un minus 1, applying the limit of 0 to a. So from the equation 1, un equal to minus a power n into e power minus a plus n into, in the place of un minus 1, substitute the formula again. So x power n minus 1 into e power minus x by minus 1 plus n minus 1 into un minus 2 has to become in the place of reduction formula. That is, in instead of un we have to substitute the value of u. In the place of n minus 1 we are substituting and we are writing like this. Now for this term we have to substitute the value of 0 to a. So take the first term, that is minus a power n into e power minus a. Then apply the limit, apply the limits there. So minus n into a power n minus 1 into e power minus a plus n into n minus 1 into un minus 2. Now un equal to, take the a power minus a power n into e power minus a should be common as taken out to be out. So minus a power n into e power minus a into 1 plus n into a power minus 1 will come, plus the next term n plus n plus n into n minus 1 into un minus 2. Now un equal to, this can be written as un, that is by second equation we have taken as un minus n into un minus 1 equal to minus a power n into e power minus a. So we are going to substitute in the place of the value. So minus a power n into e power minus a can be written as un minus n into un minus 1, since by the equation 2. And 1 plus n into a power minus 1 can be written as 1 plus n by a. If you are taking a power minus to be denominator, it should be n by a. So now un equal to un minus n, just multiply everything. So un minus n into un minus 1 plus here this side n by a into un minus n squared by a into un minus 1, then the last term plus n into n minus 1 into un minus 2. Now multiply by a on both sides. We have just multiply a on both sides. So we have a un equal to a un minus n into a into un minus 1 plus n un minus n squared un minus 1 plus n into n minus 1 a un minus 2. Now take the un to be this side, so left hand side, so it will become as minus, and then take the remaining terms also to be that side and make the equal to 0. So a un minus a un plus n a un minus 1 minus n un plus n squared un minus 1 minus n into n minus 1 a un minus 2 minus n un plus n into n plus a un minus 1 minus a into n minus 1 un minus 2 equal to 0 will come. We are multiplying with that n into n minus 1 a un minus 2. So now we are cancelling that. What we are doing now, we are cancelling. Girls, take your notebook with you, because the equal to 0, then the term was missing here. So just take your notebook with you to check the correction. In the notebook yesterday I have given the notes, it's correct, but here that 0 was cutted by that this side, right side. Okay, so just take a notebook and just learn. So a un and minus un get cancelled, so the remaining term minus n un plus n into n plus a into un minus 1 minus a into n minus 1 un minus 2 equal to 0. Now we are having the minus n to be this side, so divide by minus n on both sides, so we will get un minus n plus a un minus 1 plus a into n minus 1 un minus 2 equal to 0. Now we need the value of un, so take the un equal to what will happen, n plus a into n minus 1 and minus a n minus 1 un minus 2 equal to 0. Now what is the thing we have to prove? Un minus n plus a, so un minus n plus a into un minus 1 plus a into n minus 1 into un equal to 0, hence proved. So we got the term, what we need, we got the term. Okay, hope you understand this problem. We'll move for the next one. If I m comma n equal to integral over x power m log x whole power n into dx, we have to prove that I m comma n equal to integral over minus x power m plus 1 divided by n minus 1 into log x whole power n minus 1 plus m by n minus 1 into I m comma n minus 1. Now we are going to see the solution for this problem. Given that I m comma n value as x power m by log x whole power n, the integration. Here we are taking the uv minus integral of v du formula. So let us take u equal to x power m. Therefore du equal to m into x power m minus 1 dx is the differentiation formula. Next, integral dv can be taken as dx by log x whole power m. So which is equal to log x the whole power minus n dx, it can be written as. Then minus n plus 1 after the integration, minus n plus 1 divided by minus n plus 1 into log x can be again once again differentiated as 1 by x. So minus n plus 1 has to come. So this 1 by x can be moving on to the numerator, so x into log x whole power minus n plus 1 divided by minus n plus 1. Now x into log x minus n minus 1 divided by minus n minus 1. We are taking a minus to be outside in the power also as well as the denominator also. So we can be minus x into log x whole power minus n minus 1 divided by n minus 1. This minus, the denominator minus should be coming on to the numerator. Now I m comma n, we know that uv minus integral of v du. So we are going to substitute in that formula. U is x power m, v is minus x divided by n minus 1 into log x whole power n minus 1 plus integral of v du we have written. Now see the second term, integral of x into this m should be here written here, m into x into m minus 1 into dx divided by n minus 1 into log x term should be coming to the denominator. So we can write like this. So n minus 1 into log x whole power n minus 1 has to be coming. So the numerator should be x into m into x power m minus 1 dx. Now see the first term, we can add this term, so minus x power m power should be added as m plus 1 and the numerator should be same. Next term, we are taking the m and n minus should be outside, so integral over x power m and log x whole power n minus 1 dx. X power m minus 1 into x can be written as x power m. Now keep the first term as itself, and second term can be written as m by n minus 1 into, this is in the format of I m comma n minus 1. This is in the format of I m comma n minus 1. So we have proved the result. We have arrived the proof. So I m comma n equal to minus x power m plus 1 divided by n minus 1 into log x whole power n minus 1 plus m by n minus 1 into I m comma n. First two problems will come under the 5-mark question. Next we are going to see one 10-mark question. It's also important, very very important. Okay, just go through it. If integral over 0 to pi by 2 cos power mx sin nx dx equal to f of mn, then prove that f of m comma n equal to one term they have given and f of m comma m equal to one term they have given. So two things we are going to prove, but the given condition is f of m comma n equal to integral over 0 to pi by 2 cos power mx sin nx dx. Here as per the reduction formula, we have to take uv minus integral of v du. So let us take u equal to cos power mx, so d equal to m into cos power m minus 1x. Then after differentiating, cos x can be written as minus nx dx. Likewise, integral of dvu equal to integral of sin nx dx. After integrating, v equal to minus cos nx by n. Now uv minus integral of v du formula. So u into v we have written as, and integral over 0 to pi by 2 minus integral of v du we have written. Since in the question itself they have given that f of m comma equal to the limits they have given us 0 to pi by 2, so we are applying the limit. Once we are applying the limit, in the first term we are getting as minus 0 minus 1 by 1, that is 1 by 1, and in the second term take the m by n should be outside, so minus m by n integral over 0 to pi by 2 cos nx sin x cos m minus 1 cos power m minus 1 dx. This can be written as the formula, that is cos a sin b formula. So cos a sin b equal to sin a cos b minus sin of a minus b. Okay, so sin a cos b minus sin of a minus b. So we have to apply that formula. So minus this can be written as 1 by n minus m by n integral over 0 to pi by 2 sin nx into cos power mx dx minus integral over 0 to pi by 2 sin n minus 1x into cos power m minus 1 x dx. So here we have taken as cos nx sin x. So cos a sin b. Cos a sin b means sin a cos b minus sin of a minus b. So we have written as sin nx cos x, sin nx, let's see the last term, sin nx cos x into cos power m minus 1, that is a common term, minus sin of a minus b. So sin of n minus 1 into x minus sin of n minus 1 into x, then cos power m minus 1 is a common term. Okay, now we are separating the integrals, and therefore we are having f of m comma n equal to 1 by n by m minus n into, this can be as a given condition, that is f of m comma n sin nx cos power mx, so we can write like that, and minus this can be written as f of minus m minus 1 into n minus 1. This is in the format of, we are having in the place of m we are having m minus 1, and the place of n we are having n minus 1, so we can write like this, f of m minus 1 comma n minus 1. Now multiply the m by n to be the both the terms, so 1 by n minus m by n f of m comma n plus m by n f of m minus 1 comma n minus 1. Now take the f of m comma n term to be right side, so f of m comma n plus m by n f of m comma n equal to 1 by n plus m by n f of m minus 1 comma n minus 1. Now in the left hand side take the f comma n as common, so 1 plus m by n. and then cross multiply, we can get m plus n by n. Okay, then take m plus n to be this side and n to be carried over or multiplied with that the next side. So 1 by n, m by n, f of m comma n minus 1. If you are multiplying n to be on the right hand side, what will happen? N get cancelled, so the first term becomes as 1. The second term also n get cancelled, so m into f of m minus 1 n minus 1. Now take the m plus n in the right hand side to be to the left hand side. So it has to be, it is in the multiplication. Now it will be, if you are taking to be right hand side, it will become as a division, we know that. So 1 by m plus n plus m by m plus n into f of m comma m minus 1 comma n minus 1. This is a proof of the first one, f of m comma n. Next we are going to see f of m comma m. You are going to see that. Now f of m comma n. Okay. F of m comma n can be written as, that is, in the place of in the first result we are having f of m comma n. So in the place of n, just apply m. So what will happen in the place of n? So 1 by 2m has to be coming, plus m by m plus m is 2m into f of m minus 1 and m minus 1 will come. Now 1 by 2m plus m get cancelled, so half into f of m minus 1 m minus 1. Now multiply by 2m plus 1 on both sides we will get. So 2m plus 1 into f of m comma m. Then here 2m plus 1 divided by 2m plus 2m plus 1 divided by 2 into f of m minus 1 by m minus 1. Now just split the m plus 1, so 2 power m into 2. Likewise in the second term also, then cancel it and we are getting the answers 2 power m by m plus 2 power m into f of m minus 1 2m. Now take the functions to be on the one side. So 2 power m plus 1 into f of m comma n, and then this is a plus 2m is there. If we are taking to be left hand side, we will minus 2 power m f of m comma n m minus 1 m minus 1 equal to 2 power m by m will come. Now 2 power m plus 1 into f of m comma m minus 2 power m into f of m minus 1 m minus 1 equal to 2 power m by m. Since we are comes under this series now, we are substituting m plus 1 into m. So this is the term. Next one we are going to substituting m into m minus 1. So what will happen? 2 power m into f of m minus 1 in the place of m minus 1 we are substituting. Okay. And in the place of m plus 1 we are substituting m. So minus 2 power m minus 1 f of m minus 2 m minus 2 equal to 2 power m minus 1 by m minus 1. Now m minus 1 and m minus 2 we are substituting. So in the, likewise we are adding this series. So 2 power m minus 2 by m minus 2 term will be coming like this. Likewise it will be moving on up to the last term we are going, that is the previous term of the last term is 3 into 2. So 2 power 3 into f of 2 comma 2 minus 2 squared into f of 1 comma 1, which is equal to 2 squared by 2. Next we are applying 2 into 1. So 2 squared into f of 1 comma 1 minus 2 power 1 into f of 0 comma 0, which is equal to 2 power n by 1. Now adding all the series we are having that 2 power m plus 1 into f of m comma m minus 2 into f of 0 comma 0 equal to 2 power m by m plus 2 power m minus 1 by m minus 1 and so on up to 2 squared by 2 plus 2 power 1 by 1. So we are taking 1 by 2 power m plus 1 should be common term in all the terms. So we are getting the answer as f of m comma m equal to 1 by 2 power m plus 1 into 2 by 1 plus 2 squared by 2 plus 2 squared by 3 and so on up to 2 power m by 1. Since we know that f of 0 comma 0, we know that if you are applying the limit we are getting the 0 only. Okay, so we are taking this term alone, m terms alone, m and m plus 1 m minus 1 terms alone we are taking, and we are arrived at the result. Hope you understand the problem, guys. If you have any doubt, please comment me or text me in the comment box or message me personally. I will clarify your doubts, okay? And from this week onwards we are going to see the live classes, so please mark your doubts wherever you have and keep it with you. we can clarify the doubts also. One day 1 hour live class will be there, so we will directly see all of your faces also. Ready to meet you all. Okay guys, thank you.